So, in this session, we are going to look into a program which is going to emulate a time scope. So, normally we see waveforms in oscilloscope. So, similarly, we can write a MATLAB program where we can visualize the waveforms and also see the frequency components available in that time domain signal. So we are going to write a program and see both these things before going to the functioning of this program. Let me introduce you to three signals. One is your DSP sine wave. So in the DSP toolbox, this DSP dot sine wave is available. So that how to use it, and then the time scope, which is going to display the time domain waveform of a particular signal, which is generated here. Then the third part, how to use a spectrum analyzer to see the what is the frequency component available in the particular signal, which is like shown in the time scope. So, and also we have one more command TikTok, which is used to generate a delay for like executing and showing these time scope and spectrum analyzer. So let me first brief about the DSP toolbox and other commands. So this is the spectrum analyzer. So this is a spectrum analyzer app. It is actually so which you can go through in the documentation section of MATLAB if you need more details. So it uses the command called as spectrum analyzer. So spectrum analyzer where you can see the frequency components available in a given waveform. Also we can measure other things, change the color of display, see the spectrogram and all those things used in the spectrum analyzer. So these are the main functionalities. So this is the time scope, which is a library available in DSP system toolbox again. So time scope, if you see, it can show various channels of time domain signal, and we can also assign various colors for each signal, and we can visualize. Similarly, here also we can simulate and see some things and measure the values of peak and all those things in the time scope. So, and this is the another command, which is dsp.sine wave. So if you see here, they've given some examples. All these things you can see in the documentation section of MATLAB. So here dsp.sine wave, we have to give the parameters and store it in one variable, and that variable only we can plot and see for time scope as well as your spectrum analyzer. So here the frequency is defined and also a phase shift is defined, and both these things are displayed for us to visualize the original sine wave and the shifted version of it. So and there are various parameters which we can give inside this DSP command. So for further reference, you can go through the documentation section. So coming back to the program, so here we have defined a sampling frequency as 1000. So we are using the command dsp.sine wave to generate a sine wave. We can give the frequency component. We can as 100 I have chosen here. This can be very definited. The sampling rate already it is specified. I can take and keep it here, and then how many samples I want to display per frame also I can specify. So this part is for specifying the generation of my sine wave with the DSP toolbox. The second part is time scope, where we are going to display the signal which we have defined here and stored in the argument SW. So time scope, again it will need parameters like sampling rate, uh, time span in which we want to display, limits in the y-axis, whether I want to plot a grid or not. All the specifications we can give in a time scope. And third part is the spectrum analyzer, where it will give the frequency components available in our time domain signal. So it it has the specifications like again sampling rate and what method that so spectrum analyzer has to take place, like averaging method and all. We can specify as variables to that spectrum analyzer. And the last part is for displaying the waveform. It is a time delay function where we can generate all these things and display. So now let me run the program. So I have run the program. So it is given the time in my x-axis and amplitude in the y-axis. This is my generated sine wave from the DSP toolbox. And so this is the spectrum analyzer. Like what is the frequency component available in decibels. So it is like here it is spread between minus 100 and 100. So various tabs are also here where we can see the peak finder. We can move the data cursor and see what is the value at any particular point. So this grid structure we can have define and have in both spectrum analyzer and your time scope also. So try this in your program, and maybe you can try some other waveforms instead of sine wave. We can have so many other waveforms are also available in DSP toolbox. So try to apply those signals and see the frequency component available. Since we have specified as 100 here, that in the spectrum we have got only 100. Suppose we give a some other value, then the peak value should come there. I hope this deliberation is helpful for you in understanding how to create a signal using DSP toolbox, how to display it in time scope, and analyze it with the spectrum analyzer. Thank you.